Good evening, everyone, and welcome back to Incognito. This is episode 3 of our IT Week series, and today we'll be tackling constraint and op- optimization with Ma'am Grace Tacadao. I am your host, Leah Mendoza, and today I am joined by one of my seniors and the previous Access president, Kuya Marco Davon.
Oh,
Hi, Kuya Marco.
hello.
All
So hello everyone. I'm Romel Marco Dabon. You can just call me Marco if ever we ever interact again in the future. So I am a fourth year computer science student. I am senior again.
Mhm.
And of course, the current fourth year representative and the previous access president of last school year. And move on
Ooh.
to get the episode of Ikaw Talk.
So how are you doing, Kuya Marco? Since this is like your first time on the podcast.
To be honest, at first, right now, I don't, since this is supposed to be just a conversational kind of mood with regards to a podcast as compared to presentations like thesis defenses, like what the previous thesis defense I had last semester. So it's not really in me to be really prepared. Given that podcasts are mostly incognito, or rather, yeah, we just wing it. But compared to thesis na prepared dapat talaga.
Yeah.
There's a flow, there's a certain flow, like the presentation proper, the question and answer. So this one compared where this is there's a dynamic conversation here.
Yeah.
So more or less, and given that I'm the host, not the guest, so this is so this is a new learning experience for me. But still, it's a very fun one to be in.
That's true. So for our guest today, since IT Week, we are focusing a lot more on each of the courses. We took a speaker that is befitting for each of the courses. And I believe today is focused on the CS department,
Oh, okay.
right? And uh, today we'll be talking about optimization and constraint programming with Ma'am Grace Tacadao. I believe you are a figure that is very much well known among the
Oh, really?
alumni.
Really? Siguro because I used to be the chair of the CS. Yun.
Really?
So
So,
before Sir Tony, so I was the chair.
oh, Ma'am Grace, since we barely know each other, since I was not able to be under like your tutelage, tell us about yourself. Like,
Okay.
how long has it been since you've graduated, and what were the subjects that you taught?
Okay. Um so I'm a faculty member of the computer science departments for 20 years now. But I'm on study leave. So I am currently a research PhD student at the Insight Center for Data Analytics at the University College Cork, Ireland. But I'm but I'm still not in Ireland, so I'm still here in the Philippines. So I'm working under the supervision of Professor Barry O'Sullivan, and who's an award-winning academic in AI, among other things, and Dr. Begum Genk. So she's a postdoctoral researcher and a representative of women in AI in Ireland. So I'm working with really lovely people in the European AI community. So I consider myself very lucky to to get in insight.
Oh, wow. Actually, I'm really interested in the AI field. Actually,
Dude, that's nice.
That's why we entered the CS field in the first place, Liam.
right,
Oh.
right.
And,
Wow.
what's your since speaking of AI, so I would like to ask a little Liam, so just a little bit of an context. So Liam, are you planning to study AI for your thesis this semester?
Actually, for me personally, I was like looking into different AI topics. Hold on, let me just bring out my like little note here, since Father Denny asked us to like do like a small activity. That some of the topics that I was actually interested to like study within my field of computer science is actually one is like automated reasoning, and another is
Oh.
evolutionary computing.
Oh, okay.
Some of the others are mostly math foundations, such as game theory, graph theory. So those are the main topics that I actually want to study. So, Kuya Marco, On the other hand, you have already gone through like the thesis, still going through
Yeah.
like the revisions. How about you? What was the topics that you want to study?
Rather, so the topics I wanted to study was during the thesis proposal phase was, of course, was similar to AI. However, I wanted to focus on more on image recognition since I am a
Mm.
photographer. As I do
Oh,
photography as a sideline since I want to study AI and its effects on optimizing or rather or enhancing my photos so that I have an easier time editing my photos and at the same time it would help me get more better images through AI. But it's
because
just more of a concept really.
But what was the thesis that you end up proposing? Or you finished with your thesis,
Yes,
Marco?
ma'am. Yes, we
So
just finished
minor
what was your
revisions, right?
thesis?
so my thesis was about it's just something basic really, ma'am. But our thesis is about using image recognition to detect the kinds of basketball shots that the
Okay.
NBA basketball players did using photos
Oh,
in order to assist photographers in in selecting shots that seem to be qualified to be sent for media outlets or
oh.
magazines. So it's more or less a study on using AI to optimize the selection of images using image recognition, using
Okay.
selecting
So image
actions.
processing.
Yes, po,
Oh,
ma'am. And
It's a very interesting field.
yes, ma'am.
Yung
Given
image processing in general is a very interesting field.
yes, ma'am. Given
So
the
what did you use? You used deep learning. What kind of algorithms did you use?
So I use deep learning with the approach of
Nice.
convolutional neural networks. So I use
Oh,
Google's Inception V3 along with an implementation of the visual attention mechanism as well as
nice,
in
nice.
order to optimize the prediction accuracy of the inception of the Google's pre-trained. So since our approach was transfer learning,
Yeah,
so
nice, nice.
we use pre-trained in order to optimize also to optimize our training process during the experimentation period of our study now.
That's nice, nice.
all
So
of these
so
terms are like floating around in my head.
you'll get used to it, Liam, whenever you're gonna approach thesis two next school year.
I
Yes,
hope I
we'll
do.
have to get used to these terms, particularly if
So
you're interested in machine learning and deep learning.
I see.
all right.
Ma'am, I would like to ask you, since like you're pursuing a higher education right
Hmm.
currently, right? Like, what can you tell me more about like the purpose of higher education? Like, why pursue higher degrees?
In my opinion, um, everyone should be taking. I mean, everyone in our field should actually aim for a graduate degree. So right after the undergraduate, because the field that we are in is so fast moving. So what may be relevant this year might not be relevant in the years to come. So I would really encourage everyone in our field to take a graduate degree. I found some of our alumni who actually did, and it's kasi when they were in college when they were still pursuing their undergraduate degree, they were not the kind of people that I would suppose or interested to pursue a graduate degree. But then they end up pursuing a graduate degree. Kasi yun na nga, because our field is very fast moving. Ako, I took my I've graduated from my undergraduate degree uh um for 21 years ago, and then 11 years ago from my graduate degree from my master's. So it took me quite a while to go into postgrad. So if you ask for my advice, I'd say that just take 1 to 2 years in between degrees. 1 to 2 years of interval between degrees would be better as compared to what I did, which is 10 years. So that's a lot. So much have happened in the field since. So if you want to, I encourage you to take a graduate degree right after college. Pero siguro just spend 1 to 2 years in the industry. tapos yun, do a graduate degree. Ngayon naman, if you are interested, if you like studying, if you like learning, then I would suggest that you also try pursuing a PhD afterwards. Kasi parang in our country, PhD in CS is not super normalized, but it has to be normalized. You getting a graduate degree and then getting a postgraduate after should be normalized because of yun, because of how fast moving our field is.
So that's very interesting, ma'am. And I would also like to ask, ma'am, with regards to your studies, with your graduate studies, ma'am, since since currently you're on a study break right now, ma'am.
Yeah.
So when would you, so for your so I would just like to ask, ma'am, how many years is your current your degree right now, and when would you be back as a faculty?
I think this will take me siguro mga around 6 years. Normally a PhD would take 6 years. It depends on the country where you're taking it. In the US it would take you 6 years. I mean, 6 years. 6 years on average, because you have to take some coursework, and then before you can concentrate in your thesis. In Europe, you can opt to, there are some universities who would offer PhD degrees that contain both coursework and thesis. But my degree, yung research degree ko, research PhD degree, I went directly into thesis. So I went directly into research. So although it's not, parang I'm building my thesis bit by bit. So parang one chapter at a time. Ganon.
Oh, so like I have a question. How different is the undergraduate thesis from the higher level thesis?
When
it takes 6 years for a PhD.
Yeah. For undergraduate, the thesis, as much as possible, although I would assume na Father Denny might have told you, is Father Denny your CS teacher? Okay, so Father Denny might have told you to aim for a contribution to the field, but I think that that's a long stretch for an undergraduate degree. So it would be enough that you apply a certain technology or a certain concept to a real world problem, and then show that it works. I think that would be enough for an undergraduate degree. So for a master's degree, you should introduce something new. But for a PhD degree, you should introduce a new theory, a new definition of the problem. So it's several folds more complicated than your undergraduate thesis. Yeah.
I mean, it's really difficult of thinking something new, but how much more?
That is correct. That is super correct. Every time you think of, this is something novel, this is a new problem, parang you thought that only you have thought of that problem or have defined that problem, but lo and behold, when you search in scholar.google, you would find that there is in fact a definition of the problem already. So yeah, that's the difficult part of doing research, and it's part of doing research though. So the best thing that you can do is you have to be creative enough to look for some other way at looking at the problem. So you have to look at the problem at different angle so that you can introduce something new. So you have to be inspired. I think the best way is for you to read a lot. So it's not enough to emphasize how reading and learning in CS is really important, because again, as I've already said many times, it's a fast-moving field. Okay, it's really interesting. It's fun to be learning CS, but there are some there are some precautions to it. You have to be always willing to learn. So the things that you've learned in college, like for example, the programming languages that you've learned using in your undergraduate degree might not be the same tools that you will use when you will be in the industry, or when you will be doing a graduate degree. So prepared. So, and it's not. I mean, it's not. It's not bad at all. Basta you are willing to learn. So you have to be really teachable, and you have to be willing to learn.
Learning never ends.
Yes, learning never ends. You cannot say the same for math or other fields, for example, kasi sa CS, there are a lot of breakthroughs now which would really make it to the textbook level. Now, the textbook that you have 3 years ago might not be some of the concepts that are in that textbook might no longer be applicable in currently. So in this year, ganon. So for instance, yung sa deep learning course, I used to teach this deep learning as an elective course in CS. So before the pandemic. So I remember yung if you have been using TensorFlow for deep learning, for instance, the development is so fast. Na yung the code that I've written 2-3 years ago will no longer work in the current version. So in the current version of that particular language, so I have to rewrite most of the codes. So ganun siya ka fast. And what seems to be parang advanced at that time is no longer advanced now. So there are some more advanced more advanced architectures, for instance, in deep learning right now. So ganon.
Wow,
There's one.
I guess you
Wow.
could say that CS people are really built different. We breathe as we learn, or is it we learn as we breathe?
We
I can
breathe
Yes.
as
definitely
either.
either way.
Regarding TensorFlow, ma'am, if there was one thing I've learned during my deep learning experimentation during my thesis, it's that packages are a big headache to install.
Yes, yes. Those who took my course also, I'm sure, would say the same thing. It's different. It's different every computer system. So when we tried installing it in the lab, okay, whatever whatever commands we used for installing TensorFlow in the lab would no longer work in our own machines at home. So
Oh
that's how
no.
hard it is.
I
But yeah,
can
that's
see
that's part of the that's part of the system.
I can see
Ay,
that the road ahead of me is quite difficult.
especially when you pursue AI. But speaking of your classes previously, ma'am,
Hmm.
before you went on a study break, what subjects have you taught the
Um.
batch before
Okay, so let me
the batch
enumerate.
before me?
I taught C programming, C programming, a bit of Java programming, and then I also taught programming languages, theory of algorithms, computer networks. I also did. I also taught machine learning, deep learning, thesis one and thesis two. I also used to teach SAD and systems design, but um, systems and architecture subjects in general are my weakness. So I don't find them as interesting as the rest of the other subjects that I taught. Tapos I haven't taught architecture and operating systems. Yeah, and I still wouldn't teach them. I haven't taught them, and I still wouldn't teach them. I'm a hardcore software person. So
Oh.
I don't find hardware interesting. Yun.
Ma'am Grace, out of curiosity,
Yeah.
how did you come to know your field of research?
Ah, um, uh, my current research interest now and my current study is something related to my master's thesis. And even if yung undergraduate thesis, you can also build on that when you go to your graduate. Lalo na if it still is interesting for you, you can build on that when you get to your master's degree, and when eventually you might want to do a PhD, you can still build on that. So my master's thesis was on building timetables for Ateneo, for the university, using an approach called constraint logic programming. So this is something new. It's a different way of looking at optimization in general. It's a different way of looking at scheduling in general. So it was not so popular around that time. So kaya I was interested and motivated to do research on that.
I see. Actually, I'm really today's talk is really about the optimization and constraint programming, right? And
Yeah.
would you like to tell me a little bit more about what is optimization and constraint programming in general?
Okay, optimization is a field in AI that is obviously it's not as popular as machine learning and deep learning, and it looks for the best solution among all the possible solutions. So, for instance, in the field of tourism, so some might want to use machine learning to come up with a tour for a group of tourists by predicting the sequence of destinations based on past tour. But a better solution would be, the said tourists themselves know where they want to go and or whatever they want to experience. So why not come up with the least cost tour that includes all the destinations that they want to go? Okay, so that's a one of an example of an optimization problem. So you looking for the least cost tour. There is the problem has a particular name, pero it's somehow related to TSP. So if you're familiar with TSP, traveling salesman problem, so it's there are a lot of variants in TSP, and TSP is an optimization problem. So diba, you're looking for a tour of the traveling salesman that would be least cost, and that would include all the cities in the graph. So yun ang optimization.
Oh, I hear optimization problem and suddenly I'm having calculus flashbacks.
Yes. So it's mentioned in calculus, correct?
Is
And
it very related to calculus?
Pero not so much. But I think what is most related to calculus is optimization in deep learning. Okay, yung when we in my deep learning elective course, we talk about linear algebra. So we review concepts in linear algebra and in calculus, because the backpropagation algorithm, which is the training algorithm used for neural networks, actually make use of partial derivatives. So there's partial derivatives there. There's partial derivatives. So we have to include that in the discussion para lang they would appreciate na meron palang whole point itong studying calculus. Yeah, there is. So it's part of it's part of the background. It's part of the underlying theory in deep learning.
Okay, I can definitely say I had a great time with calculus. Not that I'm like scarred or anything. How about you, Kuya Marco?
Also last year, Liam. You were saying?
I'm not that scarred from calculus. No, not at all. How about you, Kuya Marco?
Me? About calculus? I think I got by. I think. Well, it was okay during the differentiation period. During the integration, it was a whole another new level of enlightenment.
In my opinion, the reason why it is quite difficult to learn math is because we don't readily see where these concepts would be applied. So we would only realize it later. Like for instance, a deep learning, we would only realize partial differentiation pala has a big role in the training of deep learning networks. So pero you cannot you cannot perceive of that when you were learning calculus. Siguro because most of our math teachers, bless them, pero might not have any idea to how it is applicable to our course. So they just generally know that CS was derived from engineering and math, but they do not know exactly where which particular field in CS the concepts that they are teaching are applicable. Yun. So
That's right.
so I think that's the reason why we find math difficult generally.
That's true, sir. That's true in most of our cases, ma'am, during our time with our classes during calculus, since teaching the concepts of differentiation and integration is in a vacuum where we are only taught how to integrate and how to differentiate, but it's not. So it's more on the how. It's less on the why. So since back in the face-to-face setting, ma'am, where in the pre-finals period, where this is that is the time where the applications of differentiation and integration in our case have been taught. So that was the moment where I slowly started to realize why we learned calculus along the way. But during the earlier periods of our classes of the semester, it's been really hard, ma'am, especially from my classmates.
Yeah.
Since yes, ma'am, not knowing the context of of calculus in our field, like computer science, ma'am.
Oh, so now I would understand why the engineering, for instance, the School of Engineering and Architecture would assign their own teachers to teach math. Siguro because they want to also introduce na how math is applicable to engineering. So now I understand.
Petition to have CS-based math teachers, maybe?
In the future, we hope so.
So since you talked about optimization, ma'am, earlier about the optimization of problems where we can approach, let's say, optimization in AI, where we can solve problems with the least cost, with the least amount of effort. So is there any kind of optimization towards the calculation of from these AIs, ma'am, where there would be a optimization with regards to performance in solving these problems? Let's say it's like optimizing the optimizing process, more or less.
Yeah. So there are already existing algorithms for that. So I'm sure you're familiar with all these gradient descent. So these are products of gradient descent, Nesterov accelerated gradient, momentum optimizer, and the best among them, in my opinion, and I think the community also agrees, is Adam optimizer. So all of these are products of years of research in the optimization field. So even before machine learning was born, or machine learning has become trendy, so these are already existing algorithms. So they just use them now for optimizing optimizing the how the prediction is found, or how everything is found in machine learning or in deep learning.
All right, ma'am. So go ahead, Liam. I'll give you the room for now.
Okay. Because lots of terms have been thrown out, and I'm still processing all of it.
You can process it slowly, 1 second at a time. Yeah.
1 second at a time to optimize the brain.
All right. So while you're still processing, so regarding the optimization process, ma'am. So you've given an example, right? Like the traveling salesman problem. But for you, ma'am, besides the traveling salesman problem for optimization, what kind of situation or problem for you has been the most interesting with regards to optimization? And also, what is the most difficult problem for you to approach with optimization, ma'am?
Hold on.
Sorry, ma'am.
Okay. I should probably turn off my CP. Hold on. Okay. Yeah. Okay. So there are a lot of examples, um, which one might not easily perceive because probably we're all bowled over by machine and deep learning. But scheduling, for instance, scheduling problems are part of optimization. Is an optimization problem. Scheduling, assignment. Ang example sa scheduling is of course yung scheduling of classes in such a way that they will not uh, get in conflict with each other in terms of yung block sections, yung teachers. Okay, that's a very big that's a large scale optimization problem. That's the one I tried to solve in my graduate degree. The other one is assignment. Yung assignment of nurses, for example, when you schedule nurses or you assign nurses to certain floors or to certain patients, that's also an optimization problem. Routing, so I mentioned this earlier, yung routing, yeah, routing TSP is part of routing. And then another one which I'm currently working on is the facility location problem. um, the facility location problem, we're working on vaccination center facility, vaccination, yeah, vaccination facility location problem. So we're trying to figure out which portion is most suitable, which areas. So given a number of candidate facilities, which facilities among these candidate facilities would be most appropriate for the population. And these facilities should also be like equidistant to the population. So that's an optimization problem. So we are also looking at allocation. How would you fairly allocate the vaccines? And yung distribution, vaccine distribution can actually be modeled as a routing problem. So this may be vehicle routing problem. Vehicle routing is you can have several vehicles. So how would you assign um, certain destination areas to each of these vehicles? And another one that I also mentioned to one thesis group, because they asked for some advice. I also told them about pickup and delivery. So yung pickup and delivery problem. So given for example, delivery rider, kunwari JNT or ano ba, JNT or yung wala tayong Lalamove, Grab. So kunwari, there are several pickup points and several delivery points. How would you come up with a route that would be least cost for a certain rider na in such a way na, di ba, syempre, pag may pick up and delivery, so some pick up points have to precede, yes, pick up points have to precede the delivery points. So, ano yung order of the points that the delivery rider has to visit, either to pick up a load or to deliver a load. Yon. So which would be least cost? What would be the least cost route for a certain rider? So that's also an optimization problem. So there are a lot of optimization problems. Pero it just requires us to dig deeper into the problem to figure out how the problem is really defined para we can say that it's an optimization problem. Ang clue siguro is when you have several solutions, tapos you wanted to find out the best one. Kunwari yung scheduling. So there are many ways to arrange the classes, di ba? There are many ways to arrange the courses into rooms, into time slots. So which one is the best? Yun ang question. So siguro the best one would be to maximize, kunwari lang to maximize the time that or to minimize the time that the students will spend on campus. So that's one criteria. But there are several criteria that you can come up with. Kunwari, if the teachers also have preferences, so make sure that the solution, yung timetable mo will respect the preferences of both the teachers and the students. So there are a lot of aspects to an optimization problem. Yun.
Actually,
Would you like your
that
time
is
management,
amazing.
Liam, to be optimized as well?
Yeah, it can. Meron
I'm
ng
using Google. I'm using Google
yung
calendars.
um optimal diet, kunwari, na which would minimize, for instance, the cost or which would maximize the benefit. That's one optimization
Mm.
problem, diet problem. Yeah.
I am actually like surely amazed about how well optimization can be applied to like a lot of fields. I was actually
Yes.
planning to
So
like ask
siguro
that much later.
because we are concentrating on machine learning, so we thought that it's the end all of most of the computing problems. Pero no, there is a different there is a different part of artificial intelligence. So optimization is still part of artificial intelligence. So aside from machine learning, kasi we are so used to equating artificial intelligence with machine learning. So it's not only machine learning in AI. So there are still
Oh,
a lot of fields.
actually, I will not lie. I'm actually very much when you were talking about your example earlier about the pickup and delivery, I was like, okay, wow, this is like being applied in businesses and business
Yes,
applications.
yes,
And I'm
yes.
just like
Particularly
thinking,
now.
and I'm just
Particularly
thinking,
now. Kasi
uh,
this problem might not exist before the pandemic, pero I'm sure that it already existed now.
that is true. It's like I was thinking like, okay, if my titles for like my thesis was not accepted, I'm definitely putting this down.
Yeah, try. Try it. Try
It's an
doing an
all but optional,
optimization
Liam.
research.
it's
Yes.
it's actually quite viable, especially in today's like it's actually very smart, like the realistic and time bound. And
Mhm.
speaking of like optimization and constraint program, what are the tools that you use like on a daily basis for like studying optimization?
Um, there are a lot of tools available, but the one that is most prominent for CP, for constraint programming, is MiniZinc. So if you want to try a different environment, it's not as savvy as some of the tools that you might be using. So you might be disappointed, but it's quite a good tool. It includes most of the we call them solvers. So you don't have when you're modeling your problem in optimization, there are already tools now which will just allow you to model the problem and not the solution. Kasi diba, we are used to coming up with our solution, like coming up with the algorithm that will find the solution for us. Eto, when you're doing CP, for instance, you will just define the problem. Okay, so that's your role as the programmer. So you will just define the problem. So there are a lot of tools available now. But yun, so if you're okay that your environment is not that savvy, you can try using. Pero the common and the common tool right now is Google's OR tools. So that's OR dash tools. So for everything optimization, so you can do linear optimization, constraint optimization. You can also do routing. They built a specific library for routing problems. So it's quite easy. So you will just there are existing examples in their site. So you can just modify the examples and it's fairly easy to do. It's also fairly easy to run. So those are the two tools that I would recommend you start studying if you're interested in optimization. So OR tools, that's OR dash tools of Google, and MiniZinc. So that's
Mm,
MINIZINC.
okay, cool. Sorry, Margaret. Can I like ask another question? I know we were like put in a like system where I ask a question, then you ask a question. But I am really invested in the topic right now. So, uh, what? So you were talking about earlier about algorithms. Are there like any specific algorithms, like noteworthy, notable algorithms that apply to optimization?
There are existing solvers. For example, in MiniZinc, there are solvers that you can choose from. So the solvers will look for the solution. The solvers will look for the solution. So you don't need to, um, but if you have a large problem, sometimes the solvers no longer work. So sometimes it would take them hours to look for a solution. So it would be best if you create a local search or a heuristic, an algorithm aside from the solver. So sometimes if the instance is quite small, the solvers will work. But if the instances are larger, so it would be 100. Let's say if you're talking about nodes in a graph for routing. So if there are 100 nodes, siguro it would take a while na for Minisync to work. Pero yung OR2 sa Google, I heard that it's really fast. So I've tried running, konti lang siya, it's a small instance, siguro mga 50 lang, 50 nodes. It works well. So it works it was able to find the solution in less than a second. So it's that good. Because if you use other tools, for example, Minisync, it would take you hours to find the solution. The one that I used before, which is no longer in use right now, it's called Eclipse. It's Eclipse, not the Eclipse Java IDE. So it's Eclipse it's a constraint logic now programming framework or tool. So I would run my model for one day, and sometimes it cannot find the solution. So that's how bad, yeah, how bad or how large the instance is. Yeah, ganon.
Oh.
I hope, since very interesting itong topic, ma'am, just based on your brief summary, brief overview, or I don't know what to call it, I hope that this would be an elective for the CS students.
Yeah, I hope
the
soon.
next generation.
Yeah.
Given that you would come back as a faculty someday.
Yes.
I hope it
Be an
will be
elective
offered to
now.
university soon.
Yes, come again. Sorry, Marco. Yes.
What, Liam?
Yes.
Can it be an elective now?
No,
It's
not.
too late. It's too late
Yeah,
for me.
it's also a bit too late. Yeah.
I mean, as for me, I don't know for Liam, but for me, it's too late.
Yeah.
But
No.
it's okay,
It
Liam.
hurts.
And maybe in the next life, maybe we will learn
It's the
about.
next life.
We will have a lecture about that in the next life.
Or when
Or
you're
next
going
life.
to take your graduate degree. Baka in the school that you're going to, if it's not Ateneo, then probably you will have a course there, a subject there that talks about optimization. Diba?
Yes,
True,
ma'am.
true.
And this topic, ma'am, do you believe this is a noteworthy topic for, let's say, this is this a beginner friendly topic for you, especially for those who are still beginning to approach computer science? Like, let's say, like the freshmen, the sophomores.
They can be learned bit by bit. So I think the important prerequisite for optimization is, of course, algorithms. So you have to have an understanding of algorithms, basic algorithms, and even algorithm design. So dapat you've taken both algorithms courses. So yung intro to algorithms and the algorithm design. And I think calculus, math would be very helpful for optimization, because there's a lot of math going on in optimization too. Yeah.
So since we're talking about, of course, classes also, ma'am, and preparations for optimization, and in optimization, let's say you would teach optimization in a class, ma'am. Do you believe in real life problems, ma'am, when it comes to applying optimization?
Yes.
Would there be an absolute optimal solution for every real life problem that can be solved using optimization?
Depending on how you define the problem. Siguro if it's real world, meaning that if you really take into consideration all parameters, I think na it's not always possible to look for the optimal solution. Kaya we come up with what you call heuristics. heuristics. These are, or sometimes approximation algorithms, where we are just approximating the optimal solution. So, lalo na if it's a large instance, if it's a very large instance. Because if you're talking about real world instances, I would assume that these are large instances. Yeah. So it might not be possible to look for the optimal solution in a given time. Kasi there might be several combinations of several combinations that we are talking about. So perhaps perhaps you need to use a heuristic for you to be able to look for, to come up with the optimal solution. Siguro hindi siya super optimal, pero at least the best so far the solution. And that's okay. For some instances, or for most instances, yung suboptimal, we call it suboptimal solution, is already okay. Is already a good solution, good enough solution that uh, can be used in real world. Yeah.
But however, ma'am, do you personally believe that somewhere in the future, in the far future, there would be an algorithm that would solve the most, or the absolute optimal solution for every
Yeah, I
problem?
think if we have the hardware to solve it, kasi ang problema lang naman is the hardware. Dapat the hardware has to be super fast enough to look at all the possible solutions. So remember yung ginawa ni Doctor Strange in Infinity War, ba, the last movie, the last movie. Diba, he tried to look at all possible solutions, and only one and there's only one possible scenario that they will win. So parang ganun siya. So that one possible scenario is the optimal solution that we're looking for. So if we are fast enough, if we are as fast, if we have the hardware who can process all the solutions as fast as Doctor Strange, then it might be possible for us to get the optimal solution.
I see. If only we could be like Doctor Strange, right?
Yeah.
Would that hardware be reachable in our current generation? It would be a question of the ages.
We probably need an Infinity Stone.
I think there are already existing hardwares, pero it's not as available to us. So maybe yung hardware that are only used in labs that in very big labs. So not on personal computers pa. So maybe in the future this will be available to our laptops, to our machines. So, but we have GPUs now. Although I haven't heard pa of a tool an optimization tool that can also work with GPUs. So for machine learning, it is possible. You can, yung deep learning, for instance, the TensorFlow, you can install it for your GPU. So you can let your GPU do the work. You can maximize your GPU. So, so not only for your gaming, so you can also use it for your programming, for training your neural networks.
I had a small mistake using TensorFlow back then. A small trivia, because I didn't notice that the TensorFlow package that we used was for the CPU, big since we use Google Colab. So throughout our whole training period for our AI model, we didn't use the GPU at all, and we just realized it during our data gathering process.
You can use your GPU.
Yes, ma'am. So we took a long time training our model.
Yes.
For when
it will take a long time.
When we just realized, and we realized it very late, ma'am, that we could have used the GPU for faster training.
Yeah.
A very newbie mistake on our part. Yes, note that, Liam. Whenever you use TensorFlow and Google Colab.
Yes, you can use GPU.
First F to pay respects. So, Ma'am Grace. So, back then you were still like a faculty. Did you mentor any students during their undergraduate research?
Yes. So I've mentored a lot.
Can I
Ang
ask?
last.
Can I ask what are like notable experiences you've had with your mentorees?
Um, I think the most notable are, I can't remember who among them exactly, but there were, I will just ano na lang, mention um, groups in general. So there were like 3 batches of CS students who were able to present their, who got their papers accepted to a national research conference. And I think that's a very good achievement for the students. So yeah, there were 3 batches yata. Yeah, 3 batches. So yung dalawang batches, they were also able to present their papers to the conference. The name of the conference was Computing Society of the Philippines. So it's the conference for computer science papers in the Philippines. It's the top-notch na conference for CS papers in the Philippines. And they were able to do that. So we have a lot of talents. So I think that if we can only if we only know oh where to seek help, where to channel all our resources, I think that we can achieve a lot kasi we have a lot of talents. So I believe in the talents of our students. Ang gagaling. Maraming magagaling na students. Yeah, so I think yung i-channel lang yung motivation and interest, and as well as get the right siguro funding for their research. Yeah, we can achieve a lot.
Mhm. Actually, Ma'am Grace, out of like sheer curiosity again, do
Mm.
you still remember their topics like for their research?
Kasi it was the time that machine learning papers, so machine learning in general was just starting in the Philippines. So it was, most of them are in machine learning. But yung favorite ko na, I'm saying favorite because it's it's my mentee, tapos the one that they, I think the topics were also in my field, yung constraint logic programming, were also accepted in that same conference. Yun.
Oh, I see, I see. Ooh,
So
learning a lot.
in the field of papers and endless papers in computer science, I have in our batch, in our current batch of our thesis proponents, we have never received any notification or any, sadly,
You have to
any.
submit. You have to
So
submit
you have to
your
submit.
paper. Yeah, you have to submit your paper. You have to yung submit your paper to a jury who will review your paper. Yun. So you also have to be brave enough to accept the criticisms of other researchers, which I think is
Jury,
really part of the life of a researcher.
the jury
Yes,
sounds like a very, very intense defense. It's like defense
so
part two.
Sometimes
so
you got
moving
fear.
forward, ma'am. So moving forward, ma'am, when you're done with your PhD work, would you submit your work to the said panel here in the Philippines?
Yeah, pero we are, because my supervisor and the school is in Europe, so I think that my supervisor and my 2 supervisors will be the one to decide where to submit the papers. So I would suppose that they are mostly um, in the beginning of my study would be mostly in Europe. So
So
yung AI, AI
so your
conferences.
so your study, ma'am, would be credited to the university itself, ma'am. Would that be the case? If it's, let's say, the point of submission, would it from the University of Ireland? Is that it, ma'am?
Yeah. But as a faculty on leave, I can also report the papers that I've submitted and were published to Ateneo.
Okay, ma'am. So you previously described, ma'am, that that our field is a very fast changing field where
Mm,
everything is that is new today would be phased out tomorrow.
yeah,
So I have
might
a,
be.
so, since I'm a graduating student as well, ma'am. So I would also like to ask if our field is a post graduation or
Mhm.
in the field of work for computer science. Is our field a competitive one?
Yeah, yeah, I would suppose. Of course, it is competitive. So, siguro what are you in terms of competitive in terms of yung
Competitive in terms of job opportunities, in terms of
ah
skill sets, there, ma'am, in that field.
yeah, I in terms of skill set, I would say yes. But I think that uh if you are always just willing to learn, suppose na kunwari the kind of tools that the company you're applying to is using is not the tools that you've used in your undergraduate degree, it's okay. You just tell them na you are willing to learn whatever tools they are using. So as long as you are teachable, as long as you are always willing to learn, I think that you can thrive. You can thrive either in the industry or even in the academe if you plan to work also as a researcher.
Hmm. And speaking of this advice, ma'am, since most of our since my batch would be graduating next starting next school year, we're just mostly preparing now for graduation.
Mm.
What message would you give to the graduating computer science students, ma'am? Since mostly our since mostly our work would be either more on research or more on research and development. And
Mhm.
what would you advise to us, ma'am, knowing that the field itself is constantly growing?
Similar to what I've been mentioning, don't stop
Yes, sir.
learning. Full stop. Don't stop
Learning
learning.
never ends.
So we are in a field that is ever changing, parang in the blink of an eye. So if you want to remain in the field, don't stop learning. And I would also say that start your graduate degree early. So similar to what I mentioned earlier, kasi yung interval between my degrees is quite long. So um, I would say na start thinking about getting a graduate degree even before you graduate from your undergraduate degree. Okay, para you can already plan your life. So and just take mga 1 to 2 years before taking your graduate degree. So start early. So yeah, yun. So I've also mentioned this earlier na in our field everyone should really consider taking a graduate degree. So kasi seriously, we are lucky to be in a field that is so dynamic and that there is something new to learn about every minute. Other fields pale in comparison. So of course there are yun. So I mentioned this already. But of course there are also advances in math and science, but most of them are not groundbreaking enough to make it to the textbook. Sa atin, yung mga, for instance, yung transfer learning and yung attention, they were not in the textbook 3 years ago. Pero now, they have to be placed in the textbook na. So, ganun. So, I think yun yung advice that I would tell uh, the next generation of graduates.
Thank
So,
you, ma'am. But how about those freshmen or those graduating from senior high, ma'am, that are looking to go into computer science, ma'am?
Um,
Do you have any words for them, ma'am?
um, I think a part siguro of I think most of them are. I don't know with you, Liam and Marco. What were your motivation when you enrolled to CS before? Because I think that if your motivation is not will not move you enough, parang it's not enough for you to stay in the program. Okay, parang if you just find computer school, I think most of the those who enrolled in CS or in IT just find the computer school. So if that's if that is not enough motivation for you to keep on or to keep learning or to stay in the program, I think you need to look for some other motivation. Kasi
Oh,
I think that yung just if you just find the computer cool, parang and it doesn't motivate you to learn, parang it will not sustain you in your in your stay in the program. So there has to be something else. Yun.
okay. Honestly, ma'am, I just like to like say that we've actually just reached our like time limit for this episode, and I'm just amazed at how fast like time went. Isn't that right, Marco?
Time really flew by. And to answer your question, ma'am, I entered CS because I wanted to solve problems using computers and the
Wow.
algorithms.
Wow. So I think that's a nice motivation. If you like
Yes, ma'am.
solving problems, that's a very good motivation. So
That
good
motivation,
for
ma'am,
you.
kept me throughout my
Good
whole
for
stay
you.
at Ateneo. Thank you, ma'am.
Personally, for me to answer the same question, honestly, I just went into like CS because like, well, like high school me was like interested in video games, and then
Mhm.
it just like kind of just leaped forward. And I'd say like in high school, I did like my programming subjects really well, so that was also a factor for me to choose like CS.
Yeah. And you
And,
stayed. Yay.
yes.
In the program. Good for you guys. I hope that all the freshmen will also stay. And I hope that they will find the motivation that will keep them keep them in the program and will help them stay in the program.
If there's a will, there's a way.
Yes.
I do believe that as well, yeah.
Mm. Anyways, Kuya Marco and I would just like to thank you for coming on to like this show tonight. And I'd just like to say it's really been a big honor to be on the show with you. And like
Thank
I can
you. It's a
say that
pleasure.
I can also say that I really regret it that you can't that you're not a faculty right now because I would have loved to have like a subject
Oh.
on optimization. It
Yes,
really
Oh,
ma'am.
breaks
thank
my
That's
heart
you.
that it does not that we don't have it right now. How about you,
Oh,
Kuya
thank
Marco?
you.
I was actually very interested in the AI track during the course orientation back in first year, but sadly, yeah, the circumstances that led to ma'am's study break and uh, and no opportunity to study under her was a shame. But it's okay. There's always the
Oh,
next opportunity.
There is always
yeah.
the next time.
Yeah.
So, ma'am, is there any parting message that you would like to tell like our audiences listening in to our podcast right now?
Um, just keep learning. I think that I haven't stressed this if I haven't stressed this well enough, just keep learning. Don't stop learning. I mean, we are in a field that changes very fast. So please keep learning. Full stop.
We learn as we breathe.
Yes.
And I would say that that is a wrap for this episode of Incognito. I'd like to thank you again for coming on to this show. And
It's a pleasure.
it's also been a pleasure to talk with you, Ma'am Grace.
Yeah,
So,
it was a very great opportunity to talk with you, ma'am.
mm,
Thank you for the time.
I'm gonna like chime in with a bit of incognito like like what's it called? Support. So like make sure to tell everyone that the show is available to listen for free on Spotify, YouTube, and Facebook. So to keep up with Incognito and everything CS in Adu, make sure to follow us on Twitter at adu_CS. And as always, let's explore the incognito together. Bye guys.
Thank you and goodbye.